Okay, welcome to Lakshya Academy. This is the 23rd part of excretory products and their elimination. Okay, in this part, we are going to learn ADH regulation. What is full form of ADH? Anti-diuretic hormone, which is also called, in the previous part, we learned about that. ADH is also called vasopressin. ADH, anti-diuretic hormone, is also called vasopressin. Okay, what is the function of this ADH hormone? How it works? ADH regulation. Whenever there is a less intake of water, when we drink less water, and whenever there is a dehydration, when more water is lost from the body, when there is a person is suffering from diarrhea. Okay, what happens here? Okay, here water level in blood is low. Okay, when there is a less intake of water, when there is a dehydration or when there is a diarrhea, okay, water level in our blood will be low. Okay, when water level decreases in our blood, that means in blood plasma, what is the percentage of water in blood plasma? 90 to 92, 90 to 92. Osmotic gradient becomes high. That means solutes increase in our blood. Okay, solute concentration increases. Okay, then what happens? What is the normal blood osmolarity? 300 milliosmoles. When the solvent decreases in our blood, when water is lost, solute amount of solute is same, but water is lost. Therefore, it becomes hyperosmolar. Osmolarity increase. Osmotic gradient is high. Okay, the when osmotic gradient becomes high, there are osmoreceptors I told you in the previous part 22. Okay, osmoreceptors are there in the hypothalamus which can detect this change. And then what happens? Okay, this is the pituitary gland. This is the hypothalamus. From the hypothalamus, this hormone is produced in the hypothalamus, and it comes to the posterior lobe of the pituitary gland, otherwise called neurohypophysis, which is stored here, and whenever it is required, it is released. Okay, the ADH receptors on the hypothalamus detect the change when there is a water level in blood is low. The ADH receptors on the hypothalamus osmoreceptor detect the change, and the posterior lobe of the pituitary gland releases ADH is released from the posterior. This is the anterior lobe. Okay, ADH level now in our blood increases because the hormone has released from here. Okay, ADH, antidiuretic hormone level in our blood increases. Then what happens? It increases the permeability of DCT and permeability of water. Okay, from the DCT and collecting duct. Okay, I showed you in the previous parts. Because of presence of ADH hormone, more water is reabsorbed from the DCT and the permeability has increased. Here there is there is absence of ADH. Here lesser permeability to the water from the DCT as well as in the CD. When because of why it happened? Because of presence of ADH. Okay, that's we are talking here. Okay, here increase the permeability of DC. Permeability for water increases in DCT as well as in CD. Therefore, from the okay, imagine this part is the DCT as well as CD collecting data. From this, okay, what is present in the DCT and CD? Renal filtrate is there, glomerular filtrate. From this filtrate, because of presence of ADH hormone, water is reabsorbed into our blood from the collecting duct and DCT. Okay, now what happened? Okay, urine now became hypertonic urine produced because water means solvent is absorbed from the filtrate. That means it becomes hyperosmolar, solute, more solute is present. You can observe again here. Okay, here small volume of concentrated urine is produced, but in case large volume of dilute urine when the hormone is not there, now because of presence of ADH hormone caused the formation of concentrated urine, small amount of concentrated urine. Therefore, water is conserved in the body and water reabsorption increases. More water from the renal filtrate absorbed into our blood and osmotic gradient here it became high. Now it becomes normal as water is reabsorbed. Okay, now let us see the opposite condition. When you drink more water. Okay, here lesser intake of water. But here when you drink more water, or when there is a less sweat from your body, what happens? Water level in blood is high, but here water level in blood is low because of dehydration, diarrhea, and less intake of water. But here you drink more water and there is a less sweat and water level in blood is high. Okay, therefore osmotic gradient here high, here osmotic gradient is low. Now what happens? ADH receptor detect the change and stop the release of ADH. Now ADH is not released. Here it is released, but here no. No. Therefore, here the level of ADH in blood increase. Here the level of ADH in the blood fall, and then there is a decrease when there is absence of ADH. You know what happens? And here there is no absence of ADH. Now because of absence of ADH, decrease the permeability of water from DCT. And here, okay, here water is not coming because of absence of that. Now the person produces hypotonic urine and less amount of water move from the renal filtrate into blood. Less amount of water moves from renal filtrate into the blood and reabsorption here decreases. Here reabsorption increased and osmotic gradient is normal. It becomes normal. Okay, here also osmotic gradient becomes normal. Okay, in this way, okay, ADH hormone, okay, functions in our body.